Hello students, in this video we are going to study logarithms, right? One of the very important topic. But many students you may find logarithm, oh it's very tough one. Nothing like that, it's very simple thing. So in this video we are going to study all the basic concepts of logarithm, okay? Logarithms and exponents are closely related. See, suppose if I write 2 raised to 5. You know what is 2 raised to 5? 32, right? And this is in exponential form, right? 2 is the base, 5 is the power or exponent, and 32 is the value. You can convert it into logarithmic form. How to write, you can write it as log of the number which comes separately, the value that you write here, log of 32 to the base, the same base. Here, what is the base? 2, that you write here, equal to 5. So like that you can change exponential form to logarithmic form. See another thing, suppose a raised to b is equal to c. Here the base is a, right? Base is a, the value is what? C. So what you write, log of c. Which side it comes doesn't matter. Okay, log c to the base a equal to b. Okay, like that you can change exponential form to logarithmic form. Now let us see how to convert logarithmic form to exponential form. So let me take the same example, log 32 to the base 2 equal to 5. It is in logarithmic form, right? Let us see how to change it into exponential form. You start from the base. Just you cross this one, 2 raised to 5. 2 goes and gives a kick, right? It is in the top of 2. So 2 raised to 5 equal to what is there left out? 32, that's all, right? You can change logarithmic form to exponential form. See another example. Log a to the base b equal to 7. You start from the base. Just to go cross, b raised to 7 equal to a. I'm sure now you are thorough with how to change exponential to logarithmic and logarithmic to exponential. Now I'm going to teach you how to find the value of a logarithmic function. Suppose we have log 125 to the base 5. We want to find the value of this logarithm. So what you can do now, I'm taking this as x. So now we change it into exponential form. Now you know how to change, right? 5 raised to x, right? 5 raised to x is equal to 125. Left side is 5 raised to something. So the right side also converted. 125 can be written as 5 raised to 3. Now the bases are equal. So you can say the power is also equal. You can say x is equal to 3. Now let us see one interesting question. So evaluate log 1 to the base 6. Log 1 to the base 6. I want to find the value of this. I am taking this as say x. Change it into exponential form. 6 raised to x is equal to 1. 6 raised to something. 6 raised to something is equal to 1. 6 raised to which number is 1? You ask a question. 6 raised to 0 is 1, right? 6 raised to 0 is only 1. So 1 can be written as 6 raised to 0. So you can say x is equal to 0. Because any non-zero number power 0. Any non-zero number raised to 0, your answer is what? 1. So 1 can be written as 6 raised to 0. Because here base is 6, so I am taking 6. So the exponents are, the powers are equal, x equal to. Now we are going to see some of the laws of logarithm. Very important thing, right? The first one is product rule. See, what is product rule? Log of AB to some base. I'm taking the base as say x. Log AB can be A into B, product, right? Log of AB can be written as log A plus log B. Base remains same. Log AB can be written as log A plus log B. Suppose there is one more A, B, C. You can write it as log A plus log B plus log C. Okay, everywhere the same base must be same. You must know the reverse order also. Log A plus log B. You write it as log of AB. Log A plus log B plus log C. Log ABC, right? That is called product rule. Now, quotient rule. See, that's the second rule. Quotient rule. Log of quotient A by B to some base, say x. Log A by B can be written as log A minus log B. You can write it as log A minus log B, the same base you give. So this is called quotient rule. And the next one is called power rule. So log A power m. So that is why we call it as power rule. Some base x. Now the power goes front. Log A raised to m. The m comes front. So you are getting m log A to the base x. So this is called power rule. And the another one is called base changing rule. So here log A to the base b. I want to introduce a new letter, for example c. So what you can write, you write logarithm twice. Log, one more time you write log. Now, how to fill this place? The letter which one you want to introduce, write it cross. Either you write here and here, or you write here and here. Okay, any one method you can do that. Okay, suppose the letter what I'm going to use, C. You write here as the base. If I write here, here I write in the top. Okay, now we fill the other two. Base here one B. Here there is no vacancy. You write here B. A, here we have a place, right? Like this you can write. So don't need to mug up anything. See, you can write in another way. I said, no, log A to the base B can be written as 2 times you write log. Instead of writing this place and this place, you can write the other two, right? Now you fill base B. Yes, here there's a base. A, you write here A. That's all. So this is called base changing rule. So even also you must know in the reverse order also. If you see something like this, you must know how to write this. See the cross you see here, the same letter. Strike it out. The remaining log A to the base B. In the previous one, the cross, both are same. C and C, leave it. Log A to the base B. Okay, so like that you can write. So that is called base changing rule. Another very important thing I want to tell you. Suppose if we have log A to the base B. If you want, you can interchange A and B. Suppose you want to interchange. What you write, 1 by, you can interchange log B to the base A. Okay, so these are some of the very, very important rules. Now let me see whether you understood all these things, right? First we studied product rule. Log of AB is log A plus log B. Quotient rule, log of A by B is log A minus log B. Power rule, log A raised to m is m log A. Then base changing rule we studied. Another result, A and B can be interchanged. You write 1 by. Okay, now let us see. Suppose you have log A, B by C. Can you say how to write? Product, quotient, everything is there, right? So you can write it as log A plus log B because product, right? Minus log C. Hope you understood this, right? Log A, base must be same. Okay, I can write everywhere the same thing. I'm giving another one. Log A square B cube by C square D raised to 4. How can you write this? Product, quotient, power, everything is there, right? So log A square, that's the first one. Log A square, apply power rule. The 2 comes front, so you can write 2 log A. Then here there is a product, so you put plus. Next is log B cube. Apply power rule, 3 comes front, 3 log B. Then divided by, so you put minus. Log C square, apply power rule, 2 comes front, 2 log C. Again D raised to 4 is in the denominator, so you have to write minus. D raised to 4, so 4 comes front, 4 log D. Hope you understood. To confirm it, I'm going to give one more. See, log root of A, B raised to 3 by 4th root of C. If you are able to write it correctly, yes, you understood the laws, right? Okay. Root of A means what? A raised to half, right? Root of A means A raised to half. 4th root of C means C raised to 1 by 4. That's all. Apply power rule now. So root A raised to half. So you can write it as what? Half log A. Half log A. Then product is there, so put plus. B cube, 3 log B. Then divided by, so put minus. 4th root of C, C raised to 1 by 4, right? So you write 1 by 4 log C. Okay, hope you understood all these things. These are very, very important things, students. Now let me explain how to use logarithmic table, right? So how to take logarithm and how to take anti-logarithm, I'm going to teach you using this log table. Okay, so this is a log table. Now let us see how to use logarithm table, right? So there is logarithm and anti-logarithm. Please listen how to do this. So suppose I want to find log of 23.16. When you take logarithm, you know there are two parts. So before the point, you can see there is an integer part, right? 23. So and after the point, two digits here we have 16, right? When you find the logarithm, there are two parts. One is called characteristic, another one is called mantissa. Characteristic to write, you no need for any table. By seeing this, you can write the characteristic. See, before the point, you see how many digits are there before the point, 1, 2. 2 digits are there, so you write 1 point. Suppose there are 3 digits, you write 2 points. Suppose there are 5 digits, you write 4 points. 1, reduce it. Here, before the point, you have 2 digits. So reduce 1, you write 1 point. Okay. Now you have to find the mantissa. To find mantissa, you have to make use of log table. Please listen. 2316, right? In the log table, here 2 digits number will be there. 2 digit number. So if for the first 2 digits you have to see this left end, for the third digit you see the top, and for the fourth number here some mean difference given. Okay, so 23.16 means here for 23, in the top for 1. 1 means it starts with 0. Sometimes students make that mistake. It is the first number will be 0. 0, 1, 2, it will be like that. Okay, so 23, 1, this particular number. Then in the next one is 6. So the mean difference for 6, the same line for 6, what number you have? These two you have to add it. Okay, now let us see using the log table. 23, this is the log table. 23, 1, 6. Yes, here we have 23, right? 23, 1. This is the number. 3636, right? 3636, 1. Then 6. Mean difference 6 in the same line. So here the number is 11. So you have to add it. Which two? 3636 plus that 11. So if you add it, 3647, right? So you have to write 1.3647. Hope you understood this, right? Like this you take the log. Suppose I'm taking a few more examples. Suppose you want log of 2.316. Can you say the characteristic? Before the point, you see how many digits? Just 1 digit. So you put 0. Now logarithm for all the 4, 2316, so same thing. So you write 3647 like previous one, because I have taken the same thing. Okay. Suppose the question is log of 0.2316. So now before the point, no number. If there is one number, you write 0. If there is no number, if there is 0 number, -1. That -1 we write like this. You read it as bar 1. Bar 1.2316. 3647. Suppose the question is log of 0.02316. Please listen very carefully. If the point comes here, that is 1 digit, 0 point. Here -1, here -2. -2 we write bar 2 point. Now zeros and all leave it. 2316, 2316, the same thing. 3647. Suppose it is log of 0.0002316. Here it is 3 zeros, so write bar 4. You make it easy like this now. Now 2316, it is 3647. Suppose it is log of 0.1, 2, 3, 4, 5, 6. Now count how many zeros? 1, 2, 3, 4, 5, 6 zeros. You write bar 7.3647. So you can save time. First initially just count and write, but later you can do like this. Okay. Now I'll give another one. Suppose the question is log of 7, that's all. Log of 7. No point. Point means 7. Point is not there, means it is at the end. Okay, so before the point, how many digits? Just 1 digit. So you write 0 point. For 7, how can you check it? Please listen. Some students will be searching here starting with 10. 7 is not given. No, not like that. 7 means you look for 70. 70. Where it is? Yes, 7 means you have to look for 70, 0. 70, 0. It is what? 8451. Your answer is 8451. Okay. See another example. Suppose I want to find log of 142. Point is at the end, right? So 142. Before the point, 3 digits you have. If you have 3 digits, you write 2 point. 142. So 14, 2 you have to see. 14, 2. Please listen. 14, 2. Yes, 14, 2 means it is not 1, 2. It is 0, 1, 2. This one, 1, 5, 2, 3. 1, 5, 2, 3. Okay. Just we see one more example. If our logarithm, suppose the question is log of 2, 3, 1, 6, 4, 2. Something like this. Point is at the end. Before the point, how many digits? 1, 2, 3, 4, 5, 6 digits. 6 digits, so reduce 1, 5. So characteristic is 5, 5 point. Using logarithm table, you can find for only 4 digits, right? So you have to round it. You can't find the log of the whole thing, right? So only it's 4 digits. 1, 2, 3, 4. You see the fifth number. If it is 5 or more, add 1 to this. You may consider this number as 7. You see 2317. But now it is 4 less than 5. So leave that. 2316 you see. 2316. Please listen. 2316. The same number what we have written earlier. 3647, right? 3647. Okay. Hope you understood. This is how you have to take logarithm. Now let us see how to find anti-logarithm, right? So you have to turn the page, right? Sometimes we'll take anti-logarithm, students will be searching log page, okay? That you have to be very careful. When you take logarithm, take log page. When you take anti-logarithm, you change the page, okay? So suppose my question is anti-log, short you can write like this, anti-log of 2.3146. Anti-logarithm you find only for the points after the point, after the decimal, the numbers after the decimal, 0.3146. If you take the anti-logarithm, it starts with point only, okay, point. So here also 4 digits you can find. Here the question is 3146. Don't worry about the characteristic. We'll see. I'll tell you what's the use of that. Okay, we are finding anti-log only for this part. 3146. See, 31. Same method. 31. 4. 0, 1, 2, 3, 4. And 6, 6 it is 3. So you have to add it. 2061 2061 and 3. Add it 2064, right? 2064. 2064. Now what is the use of this 2? So before the point there is a 2, right? Characteristic. If 2 is there, you keep the point after 3 digits from the left end. From here, you count 3 digits. 1, 2, 3. So you keep the point here. Suppose it is 3 point. After 4 digits, you keep the point. Point should come at the end. Okay. Suppose 5 point something. Let us see how to do that. Okay. Let me explain few more sums of the same type. Anti-log of. Just I'm changing the number alone. 0.3146. So find anti-log of 3146. You are getting 2064. Where to keep the point? Here 0. 0 means after 1 digit, right? If 2 means after 3 digits, right? Here 0, so after 1 digit. So your answer is 2.064. Suppose the question is anti-log of bar 4.3146. It is just the opposite of logarithm, right? So 3146 you find you are getting 2064. Bar 4 means before that you keep 3 zeros, right? So 0.000 2064. But I'll give another question. Please listen. Suppose the question is 6.3146. For 3146, it is 2064. Here 6 point means after 7 digits. So 1, 2, 3, 4, 5, 6, 7. This is your answer. Okay. Hope you understood. Now you are thorough with how to take log and how to take anti-log. See, what are the uses of logarithm in calculation? You can do multiplication, you can do division, you can take some power, some square root or fourth root, whatever it is, you can find very easily using logarithm. Okay, but using logarithm, what answer you are getting is an approximate value, because you know for 4 digits only you can take, right? Okay, let us see few calculations. First, I'm going to explain how to multiply. So, for example, I want to find 15.26 into 127.4. Listen, I want to find this calculation. I'm not going to do all the steps. I'm telling you how to find this product. Log of AB, you know, log A plus log B, right? So here the method is you find the logarithm of the first number, logarithm of the second number, add it. Find the log of first number, log of second number, add it. Then you take antilog, that's all. Okay? Find the log of both the terms, add it. Why we are adding? Because multiplication. If it is division, you have to, instead of addition, you have to use subtraction, that's all. Okay? So first you find log of 15.26. All of you know how to find. Okay, you can do the calculation. Before the point, 2 digits. So 2 digits, so 1 point. 15 to 6. 15 to 6. Logarithm 15 to 6, it is 17, 1818, and you have to add 17, 1835, right? So 1835. Second number, 127.4. Before the point, you can see 3 digits. So what's the characteristics? There are 3 digits, so you write 2 point, right? 1274, 1274, logarithm 12, 7, mean difference 4. So 4 means 14. 1038, 1038. That 14 you have to add it, right? So 2510, 1052 you are getting. 1052. The two answers you have to add it because it is multiplication. While adding you are getting 7, 8, 8, 2, here 3, right? Don't write this as your answer. No, you have to take antilog of this. Already you know how to take antilog, right? Antilog means only for this part you take the antilog. This 3 is for where to keep the point. If 3 is there after 4 digits, you keep the point, right? So after the point, 2887, antilog. So take the correct table, right? So we have to find 2887. 2887 is 3. 1941 plus 3, 1944 you are getting, right? 1944. You are getting 1944. Where to keep the point? Here 3 points. Okay, before the point 3 is there. So after 4 digits. So 1, 2, 3, 4. You keep the point here. So this itself is your answer, 1944. Like this you can multiply. Okay, now let us see for division one question, right? Sub question is 127.4 you divide by 16.7. So to multiply what we did, you take the log, add it, antilog. So for divide, take the log of both, you subtract it, then you take antilog, because log of A by B means log A minus log B. So you take the log of numerator 127.4 before the point 3 digits. So 2 point, you can check the calculation later, you can check the logbook later. Denominator 16.7 before the point 2 digits, right? So write 1 point. 16.7 you have to see, you will be getting 2227. You have to subtract it. All of you know how to subtract it, right? Then you take antilog of this. Okay, you take the antilog. 8825, you take the antilog, you are getting 7630. Where to keep the point? Here the number is 0. 0 means after 1 digit. So from here 1 digit, so your answer is 7.630. Now we work out a sum for some power. See, I am giving a question, 724.6 raised to 4. You know, A raised to M. When you take log A raised to M. What is log A raised to M? M log A. So here the method is the 4 comes front. You take log of this number, multiply by 4, take antilog. That's all. Because for M log A. M log A. The power M goes front. So first you take the log of this 724.6. Before the point 3 digits, so 2 point, right? 2 point, you are getting 8601. That you have to find from the table, okay? Then this one you multiply by 4. Why? Because the power is 4. If the power is 7, you multiply by 7. So into 4. So 4, 0, 24, 2, 30 to 34. 8 plus 11, right? You are getting this one. Now you take antilog of this, right? Antilog 4404, 4404. You have to find the antilog 4404. Antilog, yes, it is antilog. You confirm that one, right? 4404. 440 is this one. Mean difference 4. Mean difference 4 means 3. So 2754 272754 plus that 3, so 2757, right? 2757 you are getting. 2757. But where to keep the point? 11 is there. So after 12 digits, means 1, 2, 3, 4. After 12, remaining 8 more zeros you have to put. Or you can say into 10 raised to 8. Otherwise, you have to attach 8 more zeros, right? If I want to write it as scientific notation means before the point only 1 digit you need, right? So here we actually the point. If I want to make it here, 2.757 into here 10 raised to 3 will come, and here 10 raised to 8. Together I can write 10 raised to 11. So from here directly you can write this also. When you do sums in physics and all, you can use this one, okay? If 11 is the characteristic, straight away you take antilog, you write like this, 2.754 into what? If 11 is there, you write 10 raised to 11. Like that also you can do that, okay? So now I'll give another question, how to find root of that. Root of 175.26. Root means same thing, raised to half. Power rule only. In the previous one, power is 4, so we multiplied by 4. Here the power is 1 by 2. You multiply by 1 by 2. Multiply by 1 by 2 means it is actually we are dividing by 2, right? We are dividing by 2. So what do you do here? This is actually 175.26 raised to 1 by 2. 1 by 2. So take the logarithm. That answer you divide by 2 because it is 1 by 2. You have to multiply by 1 by 2 means actually you are dividing by 2, right? If it is some cube root, you take logarithm, divide by 3. If it is the 10th root, you take logarithm, divide by 10. Okay, here square root, so take log and divide by 2. So you take the log of 175 before the point 3 digits, so 2 point, you are getting 2437. Divide by 2. If you divide by 2, it is not divisible by 2. When you divide by 2, you are getting 1.12. Then again 1, then 17, 8, 6, then 1, attach 1, 0, 5, right? When you take antilog, so take the logarithm, divide by 2. Now I have to take antilog. After the point only you have to take after the point. Using the table, you can find only for 4 places, but here 5 digits are there. Look at the 5th number. 5 or more, add 1 to the previous. Here 5. So add 1 here. You will make it as 1.1219. So find antilog of this one. 1219. Please look at this. 1219. Antilog 0.12. 1219. Here it is 3. You have to add it. 1321 plus 3. So 1324, right? 1324. 1324. Where to keep the point? Before the point you have 1. After 2 digits you have to keep the point. Okay. So hope you are thorough with multiplication, division, some power, right? So now I am going to teach something very, very important thing. Please listen. Some of the challenges. Okay, let us see. Listen. You know bar 1 means it is -1, right? Suppose I am writing minus 2.15 or minus 2.14 and bar 2.14. Are they same? Minus 2.14, bar 2.14. Are they same? Many of you say yes, right? Because bar 2 means -2, but they are not same. What's the meaning of that, Here the minus is for both. Minus is for both, before the point and after the point. So this can be written as -2 minus 0.14 because this minus is for both the parts. But here the minus is only for this 2. So this is actually -2 plus 0.14. Hope you understood the difference. Okay. Now please listen. Let me explain. It will be useful while do some division sums. Suppose there we have a question, say bar 4.128 divided by 4. You can do this very easily. You divide by 4. Bar 4, if you divide, you get bar 1, right? Then this 1, it won't go 0. 12, 3, 8, you write what? 2 times, right? This is your answer. But suppose I'm giving another question. Bar 4.62, you divide by 5. Suppose it is 4.62 divided by 5, you know how to do that directly, right? 4.62 you divide by 5, put a point, 9 5s are 45, right? Then 1, 2, 5 2s are 10, you 2, 0, 5, 4. So 0.924, 0.924. But for this one, how to do? Bar 4.62. So here what you do, no? The numerator can be written as, just now I explained, minus is only for that 4. So numerator is minus 4 plus 0.62. Now by 5 we have, right? So what you do now, please listen. Since we have 5, I want to make it as 5 or nearest multiple of 5. Suppose it is bar 8 means you make it as bar 10. So further what you do, that number should be added and it must be subtracted, okay? Here minus 4 we have, since I have 5, I want to make it as minus 5. Minus 4 we have, if I have minus 5, I can do it, right? So for that I need another minus 1, right? So just I am writing a minus 1, value should not be changed. If I write minus 1, I write plus 1 also. Now we combine these two. Suppose if I have minus 3 here, bar 3, but denominator is 5. So here actually I have minus 3. I want to make it as 5. So what do you do? I need another 2, right? So I have to put minus 2 plus 2. Okay, see the situation and do that. Here bar minus 4 we have. I need only 5. So I need a minus 1. So minus 1 plus 1. So now group these two, minus 4 minus 1. So it is minus 5. Simplify these two together. 1.62, right? Plus 1.62 divided by 5. Now both the terms you divide by 5. If you divide the first one by 5, minus 5 by 5, split into 2, 1.62 by 5. So first one is minus 1, second one if you divide, you will get 0.324. Minus 1 plus 0.324, this is same as minus 1, can be written as bar 1.324, bar 1.324. So hope you understood. So this is very much useful to you when you do sums, okay? So hope you understood everything about logarithm. We'll continue in the next video with some other basic concepts.